I'm starting from the first part because we can do the first part also. If the first part is not in your book, you can look at the screen. The figure shows the potential difference versus current graph for a circuit component K. Calculate the resistance of the component K when the current is 4 ampere. It's a VI graph. So the gradient.
So this question is not on my book.
I just said, no, it's no problem. You have the part B. So it doesn't matter. You can look at the question from the screen, and you can start writing from part B. Actually, if we leave this part here, it is not good. Later, it will be left over. Gradient. What is gradient? Gradient is equal to y upon x. So can you people tell me what is the gradient of this graph? What is v upon I?
Resistance.
Resistance. So gradient is equal to V upon I and is equal to resistance. We are on the point here. Examiner says he want to have current on, he want to have the resistance at 4. So I have, this is a curve. This is not a straight line. Theoretically, I should be drawing a tangent. Then it will be giving me a good answer. I can read it directly, but best is the way is to draw a tangent because it's a curve. Now let me try to fit it. Oh no. I have drawn a tangent. Here, and I want to find the gradient of the tangent. Okay, so please help me in getting the points on the tangent. I have drawn a tangent. So can you locate 2 points on the tangent? I've marked my first point here. What is this point on y-axis? Is it 4 point? My first point is 0, 5.6. Now, help me to locate the second point. This is 10. Now, how much is this? Is it 4.9? If you look at this position, it looks to be 4.9. 4.9 or 4.8? Can you tell me, you people, is it 4.9 or is it 4.8?
4.9.
4.9.
No, I think it's 4.8.
Yes, 2. Okay, 1 is 2, so 4.8.
Now, please solve this. Now, please let me know the answer.
0.9 something.
0.91 we can take. So resistance is 0. Now look at the unit, it's milliampere. So should we convert it into ampere? We need the answer in ohm. So let's convert the denominator into ampere. I have converted milliampere to ampere. The figure shows a circuit containing components K, and there is a resistor and a lamp. At low temperature, component K has a much greater resistance than resistor R. At high temperature, component K has a much smaller resistance than resistor R. State and explain the effect on the lamp when the temperature changes from very low to very high. This is a potential divider circuit, and this is necessary to identify it. This is called a potential divider circuit. At low temperature, component K has a higher resistance. So first we talk about low temperature. So at low temperature, the resistance is high. In series, voltage and resistance are directly proportional. So when resistance is high, voltage is also high. As a rule of compensator, so you people might remember it, that as a rule of compensator, what will happen to the lamp? The voltage will increase or decrease on the resistor. I put a question mark here. Here, the voltage will increase or decrease. In series, if voltage increases on one resistor, what will happen to the neighbor resistor? Voltage will increase or decrease in series? I explain here with an example. Look, there are two resistors in series. The total voltage is 10 volt. There is a 7 volt. Can you tell me, double question mark, what is the voltage on this resistor? Total is 10. One resistor is getting 7. What the other resistor will receive? Hamad?
10 minus 7, 3.
3. Okay. Now, I am going to change it. You people have to answer quickly. If I make this 7, I make it 8. What will happen to 3? Total is still 10. Question mark. What will be here?
2.
Yes. Why 2?
10 minus 8.
The total has to be 10. Acha, if I decrease the voltage on one resistor, let's see, I make it 6 volt. What will happen to this question mark? Please answer quickly.
4.
4. So now use this concept. This is called the concept of potential divider. Now, when the component K voltage increases, what will happen to the resistor? What will happen to the voltage on the resistor? Will it increase or decrease?
Decrease.
Decrease. Very good. So voltage will decrease. So what will happen to the lamp? Now the lamp is getting less voltage. Will the lamp be brighter or dimmer?
Dimmer.
So when temperature is low, lamp is dimmer.
Yes.
Now change the situation. And now make it high temperature. He says at high temperature, resistance will decrease. Voltage and resistance are directly proportional. So voltage also decreases. Let me know what will happen to resistor R.
Increases.
Voltage will increase. Good. When voltage increases, this lamp will be brighter. explanation. You have to explain the whole story, which I have explained to you people. R decreases, V decreases, V across R increases, and the lamp is brighter. This is the whole story. You people have to write here in your own words. State the name of the component K. Who is that component?
With the name of component K.
Thermistor.
It's
It is thermistor.
but then in my book there is no question. I state the component as K.
Because no problem. Actually, I think your book have divided these questions in further parts. But you can look at the screen, no problem, because the main question you have in your book, the circuit one, because I think they have perhaps tried to break the circuit, break the topics too much. So this is June 17, 21/6. Calculate in normal operation the total power. Powers are always added directly. So you can directly add up the powers. 120 plus 40 plus 40 is equal to 200 watt. Now read the next part.
Why
Read,
the
screen is not coming. Calculate the total number of kilowatt hour of energy supplied to the circuit in 3 hours. The formula for energy is power into time. We want answer in kilowatt hour. So we have the time. How much power we have? The power we have is 200 watt, but we need kilowatt. How can I convert watt into kilowatt?
Divide by 1,000.
So the formula is there. Power is equal to energy into time. Multiply this and solve it. Then he wants current. The formula says P is equal to VI. So I is equal to P upon V. Put them and solve it.
The next question.
Explain why the switches are placed in the live wire and in the neutral wire. It's a theory question. Why the switches are in the live wire and not in the neutral wire? It's a good question to discuss. Everything is in the live wire, like fuse, circuit breakers, switches. Why the switches are placed in the live wire and not in the neutral wire? Why? Because you remember the concept, live wire is at a higher potential. Live wire is at a higher potential. Actually, current comes from the live wire. So all protection, all control is needed. All protection, all protection, all type of safety needed there, and switch is also a part of control. So what would be the answer? Live wire, live wire is the main wire which takes the high voltage electrons. A switch is needed to have full control. The figure shows an incomplete electrical circuit. The circuit is there, 2 ohm resistor, then there are some gaps. A student completes the circuit and measure the current in the 6 ohm resistor. Measure the current in 6 ohm resistor. Draw an ammeter symbol in one gap and straight lines to indicate wires in the other gap to show how the student should do this. So I put an ammeter here. Let me put an ammeter here. The other gaps, let put them wires here. We do not need anything here. So we have put straight lines. Why I have put an ammeter first of all here? Why I have put an ammeter here? Why not CD? Why not EF? When I want to find the current in 6 ohm resistor, why I put the ammeter here? Please answer.
Ammeter is in series.
Yes. So ammeter should be here because we want the current in 6 ohm resistor. 6 ohm resistor will be receiving the total current of the circuit, and total current is passing through the position AB. A voltmeter is connected to measure the PD across the 4 ohm resistor. Draw a voltmeter symbol to connect it in the correct position. We need a voltmeter across the 4 ohm resistor. With the circuit completed, the current in the 2 ohm resistor is 2.5. Current in the 2 ohm resistor here, I want an arrow here, 2.5 ampere. What is the current? What is the current in 6 ohm? So you have to apply ratio method. The current in 2 ohm resistor is 2.0 ohm. How can I find the current in 4 ohm resistor? I will add them to get the current in 6 ohm. But how can I get the current here? I put a question mark. I can use a ratio method. Is 2:4, 1:2. In parallel, voltage is same. In parallel, so resistance and current are inversely proportional. It's a reverse ratio. So ratio is 1:2. So should I double the current 2.5 to get the current in 4, or should I half the current to get the current in 4 ohm? It's a reverse ratio. So I'm halving it.
We'll have it.
I'm halving it because it's a reverse ratio. Parallel. In parallel, you have to use a reverse ratio. Inversely proportional. I got the current in the second resistor. I got here 1.25 ampere. How much current will come out here? How much current will come out at question mark? So in 6 ohm resistor, I have added the two currents. Why I have added? Because in parallel, current is divided and conserved. Look at the diagram. I have added the two currents to get the final current. The figure shows the same electrical circuit with an alternating current power supply and a wire in the gap AB. Draw diode symbol in one gap and a straight line to indicate a wire in the other gap so that there is a current from right to left in the 4 ohm resistor and an alternating current in the 2 ohm resistor. So he wants to have a diode. Where should I put diode? Please tell me, where should I put diode, in CD or in EF?
The diode in is the diode should be
Where should I put a diode?
Yes.
EF. Good. Now, remember, this is the shape of the diode. This is a shape, one option. Or you can put it in the opposite shape also.
The triangle shape, right?
This is the shape of a diode. I can put it this way also, and I can put this way. Now, the problem is that 1 or 2, I know I have to put it at EF. How should I put it? 1 or 2? Look at this point. He wants current to flow from right to left.
Sir, it should point to left, I guess.
Right to left. So should I take option 1 or option 2 for diode insertion?
2.
Yes, right. Now I have taken a suggestion. I have taken a suggestion from Hamad and I have inserted it like that. So Zainab, you also please tell me. I also want to revise for the students that this is the diode. This is high resistance and this is low resistance. He wants current to go from right to left. This is right. This is left. He wants current to go like this. So please check, is it right or should I switch to other form, other option? Remember, diode allows the current in one direction and stops the current in the other direction. So does this module allow the current to go from right to left or it will not allow? This, this is high resistance and this is low resistance. So anyways, I think Zainab said something. Hamad, you didn't contribute back. So I have to change this diode position because current cannot enter from high resistance terminal. So I have to put the triangle part and then complete the circuit. Remember, diode has two functions, forward bias and reverse bias. Two lamps P and Q are connected to a battery of electromotive force 6 volt and an ammeter as shown. Lamp P has resistance 15. The ammeter reading is 0.65 ampere. calculate the current in lamp P. Remember, voltage is the same for parallel. So do this calculation.
0.5.
Give me give me a minute.
0. 0.5.
4.
Hamad, did you say something? Calculate the resistance of lamp Q. We know the total current is 0.65 ampere. And we got 0.4 ampere here. So I put a question mark here. How much current Q will get? In parallel, current is divided. 0.65 minus 0.4. 0.25. Voltage is the same, 6 volt. To solve this,
24.
the two lamps are now connected in series to the ammeter and the same battery. Space below, draw the circuit diagram. Same battery and same ammeter, but they are in series. So let's make the battery. Explain the why the ammeter reading is less than 0.65. So you will tell examiner that resistance increases in series. So current decreases, resistance increases in series. So current decreases. So reading decreases. Reading decreases. So just we keep it up to here, and that's all for today. And we will inshallah continue in our next class.